In this lecture, we're going to be talking about Python's module and package mechanism. We're going to start with modules, and modules are really a fancy name for a Python file. And Python files traditionally end with a .py suffix. So if I had stack.py, that is a Python file. I can now import that file into a Python program with the import command. For example, import stack will import that file into my program. Now it will only import stack into the current namespace. It will not import the names of functions or the names of classes in stack. So if I wanted to create a, say, stack class, and let's say that was capital stack in the stack file, I'd have to say that. If I wanted to import all of the names from stack into my current namespace, then I would have to say import, or I'm sorry, from stack import star. And that would import everything from stack into my current namespace. If I only wanted to import certain names, let's say I had functions push and pop, then this statement would just import push and pop. Now, when you see a module, you may also, if you were to do an ls, you might see both stack.py and stack.pyc. PYC is a so-called compiled version of the py file. But the reason I put it in quotes is that it really just contains bytecodes, which the Python interpreter is going to interpret. And it doesn't really speed up the execution of your program, because that's all that Python does anyhow, is to interpret bytecodes. So it does not speed up execution of the program. So what it does do is it speeds up the initial load of the program. And the reason it speeds up the initial load is because Python, with just a py file, has to convert the source text into the bytecodes. Whereas if it's loading a .pyc file, the bytecodes already exist, hence it doesn't have to do the initial overhead of converting the source code to bytecodes. The next important thing is the way that we actually are able to locate our modules. So just like we have the include flag in C++ or the class path variable in Java, in Python we have the sys.path variable, and it's a list that contains all the directories we wish to search. So first of all, if you want to use it, make sure that you import the sys module, because the path variable is defined in the sys module. And by default, the current directory is first. So the current directory, which I'll abbreviate dir, is first. And then after that, you have system-dependent Python libraries. So dependent on which OS you're on or which installation you have, there'll be different Python libraries. So you can add to this list by either prepending or appending. If you prepend, you probably want to keep the current directory as the first entry. So generally you prepend to index 1 rather than to the beginning of the list. So in other words, you might say sys.path insert, whoops, sys.path sys.path.insert, and you'd give an index of 1, and then whatever directory you want it to look at. And that would preserve the current directory as the first directory to be searched. The other thing is when you do this prepend, you mask the system-dependent Python libraries. You probably intend to do that, but just know that if you append instead, then the Python libraries will mask your directory. So it depends on whether your directory should mask the Python libraries, probably what you mean. But if you don't, if you want the Python libs to mask your directory, you should append to the system path. So that next brings us to packages. And the package mechanism is much like the Java package mechanism. So you have to have the package name must match the directory name. And a package is a collection of modules. So it's simply a collection of files in a directory. And you need a init.py file is required. Otherwise, Python will not think that this directory is a package. Now, typically this file is often empty. And this file is actually executed by Python when you load a package into your Python program. So if it's empty, nothing happens, but there's some technical reasons why this file is there for when Python's searching for packages. We won't go into them. Also, you should know that after Python 3.3, this file was no longer required. But prior to 3.3, it is, and we're using Python 2.7 in this course. So let's say that you have a package directory that looks something like the following. Let's make it be Silhouette. And it's got to have an init.py. Then let's say it has a subdirectory called graphics and an init.py with rect.py and circle.py. And finally in events, so this is a graphics package as you might have deduced. And it's going to have two types of event handlers for the mouse and the keyboard. So we have a package, we have two sub-packages, graphics and events, and then within graphics we have two modules, rect and circle, and within events we have two modules, which is mouse and keyboard. So there are different ways that we can import a package into our program. So the easiest way is just to say import, and if we say, for example, silhouette dot graphics dot rect, that's going to import the rect module from the graphics package. Now, if we want to access any function or class from this rect module, we actually have to fully qualify the name of the class. So let's say we wanted to create a rect object, we would have to write out the complete package name and as you might imagine, this is a little bit inconvenient. So the second thing we could do is use the from statement and say from silhouette dot graphics import rect. Now that puts rect in the namespace, And it does not actually import any of the functions or classes, so we'd still have to write a equals rect in order to use the functions and classes from rect. So if we didn't want to do that, we could import, we could say from silhouette dot graphics dot rect import star, and now we have all the functions and classes from rect in our namespace, so we could simply say a equals rect and get an instance of a rectangle. Now there is a slight inconsistency in the silhouette syntax. So let's say that we wanted to import everything from the events subpackage. So we wanted to import both the mouse and keyboard files. We might think that this statement should do it. After all, if we're in the Unix file system and we say ls star, we would get mouse.py and keyboard.py. But this won't do what we anticipate. And if we want to actually import the mouse and keyboard files, what we're going to have to do in the init.py file for the events package, we are going to have to define a variable called all and set it to be the list of modules we wish to import, which in this case are both mouse and keyboard. So now when we type this statement, in fact it will execute init.py because we're importing the events package, and it will look at this all list, see that we have mouse and keyboard in it, and it will import both the mouse and keyboard files. And again, we would still have to say things like a equals mouse dot say mouse event. So it only imports the file. It does not import the functions and classes from that module into your namespace. That concludes our brief discussion of modules and packages.